still think I haven't like fully gotten all the concepts for derivatives down, which is I think the issue.
All right. Yeah. So do you see my screen? Do you see f of x equals 3x to the fifth and so on?
Yeah.
Okay. So when I look at this, I see power rule.
Yeah.
Power rule. Power rule. And then I see a distraction, which happens to be a constant.
Yes.
So the power rule, x to the n, d dx, x to the n is nx to the n minus 1. If you have a constant in front, you can multiply. So if you can do as much of this as you can, as you go, that's always better. 15x to the fourth plus 15x squared minus 20x minus 0.
Yeah.
So your brain distracts you when you get to the end. You think there's some sort of power rule component here. There is none.
Yeah.
Okay, let's move on to next problem here.
Okay.
Many times, I'm sorry, go ahead.
What I think I did is I think I get too like complicated with it. I try to get as simplified as possible.
Yeah, there's a thing here where you don't even need to simplify depending on the instructor.
Yeah.
Would you like me to give you one like this to try now, or move on to something else?
No, I think the first one I get.
Okay, so there's often what I call a rewrite step, especially as a new calculus student, and a rewrite step is basically putting this into a different form that's maybe more familiar to you to be able to use the power rule. So the faster you can do that, the easier it'll be to take the derivative. Because then this is just, again, it's just a power rule question. These are both power rule rule derivatives. And then it's up to you if you want to spend more time, 40x to the fourth plus 12x to the minus 5. Do you need to put this x to the minus 5 on the bottom? That's up to you, up to your instructor.
Okay. Okay.
The variation on this one is like where you see a root or a cube root or something with a radical sign that you might see.
Okay.
All right. Let's move to, I guess these are all number 1. This is labeled weird by your instructor.
Yeah.
There are standards like you go left, right.
Yeah.
Okay. When I look at this, I see product rule, and I make a division right there and say, okay, there's the left function, there's the right function. How comfortable are you knowing your product rule?
It's hard for me to remember things by name.
Okay, so this is the u times v.
Oh, u times v, yes.
Yeah, and just to be clear, though, there's many ways to remember it. There's uv prime plus vu prime, which is great, but sometimes, like I remember it's first times the derivative of the second. I don't write this, but I say this to myself, plus the second
times derivative of the first.
First, right, and somehow that makes more sense to me than these, but you can, whatever it takes for you to remember this, you're going to use this over and over again in this course, so be prepared to do that. So y prime is x squared, derivative of secant is, do you know?
Oh, cosine.
Derivative of sine is cosine. So do you have a derivative sheet, kind of a reference sheet that you like? Let me send you one. There's many of these. I'll put this in the chat. Okay. There's many of these on the internet. I would find one and have it printed out with you at all times, or have something you can pull up on your phone or your computer, wherever you're working on. Okay. Derivative of secant is secant tangent. So derivative secant is secant x, tangent x, plus, I guess I need to move all this stuff over. The secant x and then times 2x.
Okay.
And then if your instructor was big on this, you could move the 2x in front. It's generally preferred to have polynomials before trig functions.
Yeah.
It's up to you, whatever your instructor wants. They're the ones grading it.
Yeah. Okay.
Okay, so that's product rule. I'm doing these in the order that I guess I would want you to do them in. as like a student that's trying to get this down. So I'm going to move to this one next to make it clear that this one is not product rule.
Okay.
This is not product rule. Because even if you break it right here, it's a constant times x to the 1/2. And this is a constant times a trig function.
Yeah.
And sometimes students, they do so many product rules in a row, they think that this is a product rule. It's not. And that's why this rewrite step is so important. Because if you write 9x to the 1/2, maybe you say, oh yeah, that's just power rule for tangent x.
Yeah.
Okay, so derivative here is 9 times 1/2 x to the minus 1/2 power rule plus 4. Constants always come down. Derivative tangent is, you know,
secant squared.
secant squared x. Excellent. Okay. So this becomes 9/2 x to the minus 1/2. I think it's okay to leave it like this. Some instructors want you to only use positive exponents, but that's your final answer on that one. Okay. The other two questions on here are other two that we haven't done yet as part of one. They are both quotient rule.
Okay.
So we save those for the end. They take the longest.
Yeah.
All right, so the first one here, quotient rule. It is okay. It is certainly okay in the beginning to actually write out like u is 3x cubed minus 2, and then v is x squared plus 5, and even write like u prime 9x squared, v prime 2x.
Yeah.
Eventually you won't need to do this, but it's definitely okay in the beginning. So I prefer the words bottom times derivative of the top minus top times derivative of the bottom over the bottom squared. And that helps me to remember this.
Yeah.
If you don't write out everything we put on the right here, then you have to do it as you go. And that's okay. You probably are able to do that. It's just whatever you get comfortable with.
Yeah.
So the bottom is x squared plus 5. The derivative of the top is just 9x squared minus, another thing here, I like to put them in parentheses to kind of really separate, that's v, that's u prime. So we have the top 3x cubed minus 2 times the derivative of the bottom, which is 2x over the bottom squared.
Okay.
And this is done.
Okay.
Generally you don't simplify these.
Okay. I think that's a lot of the time where I go wrong. I try to do too much.
Yeah. A lot of instructors actually will tell you like, do not simplify. At like the U of A or ASU, they do that for sure. If you're doing this like in Pearson, sometimes you can get away with putting it unsimplified and it still gives you the full answer for that.
Yeah. Just
Okay.
don't simplify.
Not unless it tells you to, which goes against everything you've been told, up until you're like, no, simplify
Yeah, that's
everything.
why it's hard for my mind to
wrap
around it, because I want things to be as simple as I can.
Yeah. Now, maybe you've gotten to this, but sometimes you have to take a second derivative, and then you definitely want to simplify this because it's really bad to deal with it as it currently stands.
Yeah.
But for just first derivative, it's usually okay.
Okay.
Okay. So this is another quotient rule, u over v. So the derivative is the bottom times the derivative of the top. So what is the derivative of a constant?
Of cosine?
Just a constant, that 5. What's the derivative of that?
Oh, 0.
0. And then this minus 2 goes with that. So it's minus 2. Derivative of cosine is?
Sine.
Positive, negative sign. So that becomes plus 2 sine x minus the top times the derivative of the bottom. The bottom is 3x squared all over the bottom squared.
Yes.
This one for sure simplifies, but if they don't ask for it, I would leave it. This
Yeah.
is generally what instructors like. They're looking for like, can you use the quotient rule?
Yeah.
You're like, yeah, I can. Okay, so that takes care of question one. Is there any that you would like to have me provide, like a same question, different numbers, related question?
I'm trying to think. For a few of them, like for 3 and wait. Yeah, so 3 and well, no, wait. Sorry, give me a sec. For 3, why did we keep the original?
Are you talking about 8x to the fifth minus 3x to the fourth?
Oh
Three.
no, sorry, I wrote it down as 3. The x squared secant of x.
That's a product rule problem.
Okay, so for product rule, you're gonna keep the. So
Yeah,
that's
so
x
product rule,
secant.
yeah, product rule is this. And there's really no substitute for doing just a lot of practice on these. So let me just give you one like this, if you're okay with that.
Yeah, sure.
So let's say y equals x cubed times sine x.
Okay.
And this is a product rule. I'm telling you, so there's no confusion here. And the split's right, right there. That's your u, that's your v.
Okay.
So take 60 seconds, see if you can work this out on your own, and then I'll work through it with you
Okay.
if needed.
Okay. So is it just x cubed cosine x plus 3x squared sine x?
Yes.
Okay. Okay. So it's
Okay.
just the u and then
It's just a product rule. Yeah.
okay. Okay. Perfect.
Okay. So how about quotient rule? Are you comfortable doing
Yeah.
one of those on your own? Okay. Should we move then to question 2?
Yeah.
All right. Find the slope of this. Okay. I can see this is written very strangely.
Yeah. My
Okay.
teacher's a little, it's hard to understand what she's.
Okay. Yeah. So the whole thing here is that the derivative is slope, but
Yeah.
it's really like a slope function, meaning it gives you the slope at every point. So the better the way this question should be written is what is the equation or what is the slope of the tangent line to the function f of x at x equals whatever it is, pi over 6 or something.
Yeah. I think that's a question on the back of the test, actually.
Okay.
About the
So
tangent. Yeah.
we're not.
That's about tangent and normal lines.
So so the other thing here is it could just say, what is the derivative? Give me the derivative of this.
Yeah.
What is f prime of x? Well, this is a product rule again. There's u and there's v.
Yeah.
So you just did this for me. Do it one more time, please. Give me the product rule for 4x sine x, and then we'll talk about what to do next.
Okay. Okay. Is it just 4x cosine x plus 4 sine x?
Yes.
Okay.
Okay. Now it says at x equals pi over 6. So there's now you can evaluate the derivative at any point, but we're going to evaluate it at pi over 6.
Okay.
So 4 times pi over 6 cosine pi over 6 plus 4 sine pi over 6. And this is where I ask you, how is your unit circle knowledge? How good?
So
not great like most calculus students.
not great. I was really good at it in geometry, but
Yeah, so I just sent you a link to a cheat sheet, reference sheet for this. Page 3 has got the unit circle on it. This will come up again, so you want to be aware of these values.
yeah.
You probably don't get a calculator on the AP. You don't.
Yeah.
So 4 times pi over 6 is 2 pi over 3.
It's in our calculator section.
Yeah, cosine pi over 6 is at 30 degrees. What is that, square root 3 over 2? And then sine pi over 6 is, I believe it's 1/2.
Okay.
So without those values, you know, you'd miss some amount of credit on here. But so this becomes pi square root 3 over 3 plus 2. And that's your slope.
Okay.
That's what they're looking for. So in short, they were asking you to, 1, get the derivative, get f prime of x, 2, evaluate at x equals pi over 6.
Okay. Yeah. I did not. I did the complete. I overthought it.
Well, what I see here is you try to use the definition of the derivative,
Yeah.
and you actually don't need that at all ever again in this course.
Oh, really?
It's gone. Yeah, it's like proofs in geometry; they never come back.
Okay.
Yeah. So,
Okay. Do you want me to share? I get that. This when it asks for just slope, I'll just basically find the derivative and then plug
yes,
it. They give me.
yes. Slope means derivative. So that you can either send it to the chat. You can either email.
Okay.
I can send you the email if you'd like. If you don't have it,
I have it on my desktop. So just the email. I got the.
yes,
link
you can just reply right to that. It'll work as well.
Okay. Let me add this. And then there was another part of the test. I'll send that too in case we have time. Okay. So the first one is the blue one, and then if we have time, the pink one is in
Okay.
it. Oh, the picture is visible. Might be a little blurry.
Okay. I see some pictures come in here. All right. I'm sorry, one more time. The blue and then the
blue first, yeah. And then the pink.
find the volume of a cone. Is that one?
Yeah.
Okay. All right, if the volume of a cone, so it doesn't look like that was given. The volume of a cone is 1/3 pi r squared h with a height of 9. It changes with respect to its radius. At what rate does the volume change when r equals 2? Is that all you got on this?
Yes.
Okay. Okay, the way that I'm reading this, and this is not written very well, I'm not trying to be disrespectful to your instructor,
No,
but
don't
it's
worry.
unclear. What I think is unclear is that the h is, or h prime is equal to 0 because it's telling you that it only changes with respect to its radius.
Yeah.
In other words, it's basically telling you to treat h like a constant.
Okay.
And that's not the best way to write this, but that's my understanding of the way to do this. Sometimes they tell you that, like, well, let me draw it differently. In a cone, they'll tell you like the radius and the height, you know, they're proportional to one another, and you have to do something over here.
Mm-hmm.
But that's my understanding of how this is written. So we may be going down a path here that isn't exactly what the instructor wanted, but I guess we'll have to do this. So we're going to treat h like a constant, which is
Okay.
probably strange, but let's do that. So you might rewrite this as 1/3 pi h r squared, because all of this is just a constant now.
Yeah.
Okay, so v prime is the constant, and then this is power rule.
Okay.
To
Yeah,
r
that's
r
what I
r
think.
prime.
I'm remembering when she went over the test in class, and I remember she did that because I kept the r squared.
Okay.
I remember that being wrong.
Now there's more to this. So it's just this is really awkward. There's an r prime. There's an implicit derivative here, but because it's saying that it only changes with respect to its radius, maybe your instructor doesn't mean for this to be here.
Yeah.
I'm sorry, there's just so much wrong with this, but
No.
this is, we'll just go with this. So you have h is 9, and r is 3, and you can carry this out from here.
Okay.
So this is 1/3 of 9 is 3. This is 6. This is 18 pi. And now we need some units. The units of volume are feet cubed.
Okay.
And then again, this is a little weird. It's usually with respect to time. But
Yeah.
since it changes with respect to its radius, it's like the radius units will be here, but usually it's a time unit here.
Okay. Yeah. It was like she kind of just like took off a piece of a whole question.
Normally this question is written in a way where they tell you that volume changes with respect to time.
Yeah.
And
I
then
took
you went,
physics last year, and there was a lot of that.
yes, and you end up doing a product rule derivative here. This is how you normally do it. So this is the correct way. It's r squared h prime plus 2rh r prime.
Huh.
Okay, and this still works because h prime is 0, but this is what I was expecting when you first showed me the problem. But there's some language issues in this, and
Yeah. Makes it
I
difficult
think,
to
yeah,
understand what you're asking.
yeah, I think you may want to ask your instructor that one if you have time before your retake.
Okay.
But let's just move on to the next question, because I'm not going to be much help on that.
Okay. Yeah. Don't worry about it. That one's worded weirdly.
Okay, write the equation of the tangent and normal lines to the following.
Yeah.
So a tangent line and normal line, you need a slope. You need a slope,
Okay.
and you generally need a point. Slope comes from the derivative.
Yeah.
Okay, the point comes from evaluating the function there. So we need to do both. So for me, the first step here would be to find f of 4, which is 4 to the 3/2 power plus 5. The 3/2 power means it's the square root, that's the 2, of 4 to the power of 3.
Yeah.
This is just a reminder if you're not. So this is the square root of 64, which is 8 plus 5, which is 13. So you have your ordered pair. When x is 4, y is 13.
Okay.
And you got that. I can see in your notes you've got that. Slope comes from the derivative. You're in calculus, you should know, okay, I got to take a derivative.
Mm-hmm.
What is the derivative? So if f of x is x to the 3/2 plus 5, what is f prime of x? And this is a power rule derivative.
Yeah.
So this number, this exponent comes out in front,
Mm-hmm.
and then you subtract 1 from the exponent.
Okay. So
The derivative of a constant is
0.
0. So you're done there. So this simplifies to 3/2 x to the 1/2 power.
Yep.
And then you have to evaluate it at the point. So this is your derivative function, this line. And then the next line gives you the slope because you evaluate it at a point. You find f prime of 4, 3/2 of 4 to the 1/2 power.
Yeah.
4 to the 1/2 power is the square root.
So 2.
2. So this is 3/2 times 2, which is 3.
Okay.
So it's really 2 questions. This is another thing I'm really, you can see why maybe this class, this is like part A and this is part B.
Yeah, she kind of, what I've noticed in this class, which has made it so hard to like understand what she's doing, is she kind of skips the simple steps
Yes.
and just like
Yeah,
goes
you want part A, which is what is the evaluation of 4. Part B is what is the derivative. Part C is what is the slope of the tangent line. And then you need to encode, you need to like deconstruct all that from this.
Yeah.
And the AP is not written this way, by the way. It'll be much clearer. Okay, so for part A, we need the slope, which we have now. The slope is 3. We need a point, which is 4, 13. And it doesn't specify the equation of the line. So you can actually use any one you want. I see on your notes you have this one. This is the one I would use because once you put the numbers in, you're done. 3 times x minus 4.
Perfect.
For part B,
don't you just do the inverse reciprocal?
Yes, so negative 1/3, it goes through the same point. So you're done. You've got y minus 13 equals negative 1/3 x minus 4.
Yeah. Okay. Yeah, I was trying to use
It looks like you're using the difference quotient again here, which I mean, I understand why, because you probably are seeing like somehow you were interpreting like definition of the derivative and tangent lines and stuff like that. But once you've crossed this threshold in this course, you never go back to those again.
Yeah. Okay.
All right. Number 5. Is that okay if we go to that next?
Yeah.
Okay. Great. Number 5. So this notation means the second derivative.
Okay.
Second derivative. There's a lot of ways you can write second derivative. That's what this means. Don't get caught up in the notation. But it's like y prime, f prime of x, d dx, dy dx. These all mean first derivative.
Okay.
This is just notation for second derivative. So to get to the second derivative, you need the first derivative. This is product rule.
Okay.
So if you be so kind, could you give me the final product rule derivative of this whenever you got it? Take as much time as you need to get that.
Okay, so x to the 8th cosine x plus 8x to the 7th power sine x.
Like this?
Yep.
Okay, so your second derivative is just product rule again. So like this creates 2 terms, and this is going to create 2 terms.
Okay.
So you just have to do it again.
Okay.
So give that a try, please.
Okay. I got all the numbers out. I'm just going to simplify it a little bit.
It just give me 4 terms. Yeah.
Okay, so negative 8x, no, negative x to the 8th sine x plus 8x to the 7th cosine x plus 8x to the 7th cosine x plus 56 x to the 6th sine x.
Very good. Perfect.
Okay. That's 1, 2.
All right, so I'm looking at the other sheet of paper you sent me, pink sheet here. Number,
Let's see. I think I only took a picture of like half of it.
yeah, and we just start.
Yeah.
I'm really curious here. What is SESC in
Oh,
parentheses?
okay. So I'm a senior in high school, and instead of like the normal out of like 100 ABC, she
Okay.
grades on a 4.0 scale,
Okay.
which is kind of confusing because all my other classes are on the
Yeah.
100 scale.
All right.
She's a little much,
Yeah.
but she grades each like section individually, basically.
Okay.
So
Okay.
I mean, you go back onto the blue one, you can look at the bottom, and those are the grades I got for each section.
Okay.
And she does that because she allows you to like retake 2 sections. So
I see. I
it's
see.
easier.
Okay. Well, number of times slope of f of x equals to 4. Is that, do we need to look at that?
I got that one right. No,
Okay, that's clear.
and we don't have to do SE either.
Just
because-
SC.
Wait, let me double check. I want to check on the scores. I want to see which ones I'm going to retake. Actually, yeah, let's do those last two because I'm going to do SC and SE. Those are going to be the 2 sections I'm going to retake.
Okay, find the growth rate of this bacteria. Yeah. Okay, I'm snipping that in. Okay, so whenever you ask for a rate, rate means slope, which means derivative.
Okay.
It almost always have units of whatever you're measuring per time. So
Okay.
like feet per second, kilograms per second, miles per second, miles per hour. This one's in seconds. They do emphasize that on the AP, like you actually get questions where you have to write the units in. So that's why this is here. But being the good calculus student that you are, you should at this point know, hey, I got to take a derivative of this.
Yeah.
So the derivative of 6 is
0.
0. Power rule, 6t.
T.
And this is also power rule.
Yeah.
Okay, so
This
okay.
section I was allowed to use a calculator on.
All right, yeah. And we'll use that here. So it wants, this is the growth rate equation. So you can get the growth rate at any time, but they want it specifically at t equals 4. They want you to evaluate the derivative at 4.
Okay.
So you're simply putting 4 in for t.
Okay.
And you get a number here. You get 24 minus 9.6. You get whatever that is.
Here, I'll do that right now. Yeah, negative 9.6.
So so we got 24 minus 9.6. What's the what does this become? 15.4?
14.4.
Yeah, and that's so it's population, like I guess it's bacteria per second.
Yeah.
We don't know what kind of bacteria it is.
No.
But that is that okay? I mean, is that's it's take a derivative, evaluate it. We did that in the find the tangent line questions.
Yeah.
Take a derivative, then evaluate it. Whenever they give you an x value, almost always you're going to take a derivative and evaluate it.
Okay. Okay. Yeah, that makes sense.
Okay. Can I move on to parts, the next one, SC?
Yeah. It's just like the sections on the graph.
So upcoming in this course is you're going to do more analysis where you're given graphs and things like that. It's
Okay.
really important that you understand that the things I'm about to say apply because you're given the velocity. If you're given the original position function, different things apply than what I'm about to say.
Same for acceleration, right?
Same for acceleration, yeah. So it's, and if you took physics, you probably made some of these graphs in your labs or class, but like here, these points right here are where it's stopped.
Okay.
I know that's part A because I looked ahead. It's because velocity equals 0, and this is v, and this is t. So it's literally where it crosses or touches
Okay.
the t-axis, or more generally the x-axis.
Okay.
So at t equals 1, 7, and 18. We should talk about what's happening from 10 to 14, but is that clear? Is it clear that it's stopped there, there, and there because velocity is 0?
Yeah, that's clear.
From 10 to 14 is like you're on the interstate and you're just cruising. You're going at the same speed. This is constant speed right here, constant velocity.
Okay.
You're just always going the same speed. You hit your cruise control and you're moving forward or backwards, I suppose.
Okay.
Although this one's forward. Okay, when is the particle speeding up? Okay, so there's a couple of things here. There's two possibilities for speeding up. Speeding up occurs when velocity is positive and acceleration is positive.
Okay.
So let's talk about when velocity is positive for this graph. It's when it's above the x-axis.
Yeah.
So the velocity is positive. I go back to the graph. Actually, let me copy this down because it's going to be, there's going to be too much going on if I don't do this. I'm going to switch colors. So here, all of these in blue, velocity is greater than 0
Okay.
because it's above. Okay, is that okay? Is that clear?
Yeah.
Now in red, acceleration is greater than 0 when it's going up and to the right.
Okay.
So in red, this is acceleration positive. That's the only place.
Okay.
So you have to figure out where are these both true.
Okay.
So we'll use the green to denote both true. And that's only in this window right here.
Okay.
Because it's both going up and to the right and it's above the x-axis.
Okay.
But there's more. That's only the first case.
Yeah.
It's also speeding up when velocity is negative and acceleration is negative.
Okay.
So let me actually, sometimes I forget that I have the ability to do all this on these format. Let me recopy the image and show you that. So in blue, velocity is negative here and here.
Okay.
Okay.
It's below the x-axis.
It's below the x-axis. And then in red, this is when it's going down and to the right. So this is right there and right there.
Okay.
So where is the only overlap? And I guess I did that in green.
It's the 1 to 3.
Yeah, from right here, from 1 to 3.
Okay.
And then this was 7 to 10.
Okay.
So you could similarly, I know it's not asking this. You could similarly ask, oh, it does ask when it's slowing down. Oh my goodness. Okay. It does ask that. All right. So let me grab this. Okay, so it's slowing down, and there's two cases for that. It's when acceleration, I'm sorry, when velocity is positive, but acceleration is negative,
Okay.
or it's when velocity is negative and acceleration is positive. There is a small shortcut here, but I don't know if you want it, because the only time it's neither slowing up nor slowing down is in this region.
Okay.
So it's everything else. It's like whatever you didn't cover in the, like, from 7 to 10 and from 1 to 3, it's speeding up. So it's slowing down in all the other regions except for the one where it's constant.
Oh, okay.
That's like the shortcut.
So basically, if you get the where it's speeding up, you can easily just
Yes.
get it speeding down by
Yes.
process
Yes.
of elimination.
Yes. Do you want me to go into any more detail on that?
No, I get the slowing up and speeding down.
Okay. Okay. So let me copy this graph down one more time. And again, I'm gonna send this to you, notes at the end PDF. The next question asks forward. Whenever it's moving forward.
Yeah.
How do we want to do this? If velocity is positive, and this is why this probably should have been part A, if velocity is positive, it's moving forward. So the analogy I sometimes make is like, you have your car and or whatever you drive. If you're stationary, if you're not moving, your velocity is 0. But if you're moving forward, your velocity is greater than 0. If you're moving backwards, your velocity is less than 0.
Yeah.
So that's why it's let me use a different color here. Blue again. It's here, here, and here. Just because it's literally because it's above the x-axis.
Yeah. Okay.
Okay. So backwards is going to be when it's below the x-axis.
Okay.
Okay, there it is. So v less than 0, it's going backwards. Excuse me, it's backwards in here. Okay.
Okay.
When is the particle's speed the greatest? This question, I'll type some words for it. Because you're given the graph of velocity, I guess we should assume your retake will be like this. The answer to this is the location. It's either the lowest or the highest point on the graph.
Okay.
So I was going to say min or max, but it doesn't necessarily have to be that. But it's like, if we look at the graph one more time down here, you're like, well, it's either here or it's maybe here or here. So so well, which one is it? Well, that's like 3, and that one's -4. Did your instructor handwrite this? Wow. Okay.
Oh no, I did.
Okay.
The numbers weren't put in. I put the numbers.
Oh, those weren't put in. Okay. Well, how did you know? How did you know which? Oh, I see. 0 to 18. All right. I guess that's reasonable. So that's how you answer that, is it's either the highest or lowest point in the graph, whichever is bigger. That's how you decide.
Okay.
Because speed is the absolute value of velocity. So it doesn't matter whether it's -10 versus +8. It's whichever is further away.
Okay.
We got a couple minutes left.
Wait, so sorry, really quickly. So would it be 3 or -4?
I'm sorry. So the answer is that the speed is -4, but it occurs at. They're asking.
Oh,
when.
okay. So the highest point basically for y, kind of.
Yeah. So the answer is t = 3 because it occurs right there.
Whatever that time.
I was telling you what it is. It's like, what is it? Where is it?
Okay. Okay. That makes sense. Okay. I mean, I think that's good.
Okay, so this is kind of what you can expect if you do another lesson with me.
We just got another test back, so I'll probably be
Sure. If you ever need a time that's not available, you're welcome to text me and I can add one if I'm able to. But thanks so much for scheduling. I look forward to helping you. And I'll send you the notes and the screen recording out shortly. Give me about
Perfect.
an hour for things to upload and stuff. But
No problem. Thank you
that's
so
it.
much.
You're welcome. Have a great night. Bye now.